The world's first atomic power plant was put into operation near Moscow in 1954. It supplied the first commercial power derived from the splitting of the atom. As the production of atomic power becomes cheaper, the building of atomic power plants expands, especially in areas poor in other sources of power. As a result of the Soviet Communist Party's plan for developing atomic power in the USSR, an atomic power plant is being built in the Urals near the village of Beloyarsk. The Beloyarsk atomic power plant, named in honor of Igor Kурчатов. Director, Jacob Cooper. Camera, Alexander Teletnikov. The Sverdlovsk Film Studio. The first unit of the 100,000 kilowatt atomic power plant was completed and commissioned in 1964. This is the central hall of the atomic power plant. The nuclear reactor which supplies the power. Deep down, a chain reaction of nuclear fission of uranium atoms takes place. The reactor is charged with fuel channels of steel pipes and graphite. They contain the nuclear fuel, enriched uranium. Here at the wall of the reactor hall, you can see the reserve fuel channels. The reactor at the Beloyarsk atomic power plant is a further improvement of the reactor of the world's first atomic power plant. Its thermal capacity is 285,000 kilowatts. Its principal components include the graphite stacking, the fuel channels, the control channels, and the scram channels. The core of the reactor is adjoined by the graphite reflector, which reduces the leakage of neutrons from the core. The graphite stacking is in a steel containment. Biological shielding of graphite, cast iron, water, and concrete surrounds the reactor from all sides. Heat is removed from the reactor by boiling water and steam in the boiling and steam superheating channel. This is a cross-sectional view of the boiling channel. The pipe with water is surrounded by uranium. The heat, generated by uranium nuclear fission, heats the water. A mixture of water and steam is formed. This is a steam superheating channel. Superheating of steam is a specific feature of the Beloyarsk power plant. The superheated steam is fed directly to the turbine. The electric power of the plant feeds the Urals power grid. The world's first atomic power plant employed a two-loop system. Due to low steam parameters, its efficiency did not exceed 17%. This is not enough. To increase efficiency, the steam parameters must be raised. Such were the steam parameters envisaged in the design of the Beloyarsk atomic power plant. These parameters were achieved by utilizing the principle of superheating steam in the reactor. This is how the circuit of the power plant is modified to obtain superheating of steam in the reactor. The water boils in the boiling channels of the primary circuit. The boiling water delivers its heat to the water of the secondary circuit in the steam generator. The saturated steam of the secondary circuit is fed from the steam generator at a pressure of 105 atmospheres to the steam superheating channels, where nuclear superheating raises its temperature to 480 or 510 degrees centigrade. This is a flow diagram of the first unit of the Beloyarsk atomic power plant. It can be regarded as a transitory stage to the even more advanced single-circuit steam superheating system. The high steam parameters achieved at the Beloyarsk atomic power plant have made it possible to employ serially produced turbines, generators, and turbine shop equipment made by Soviet industry. Cast iron doors weighing many tons and concrete boxes shield the equipment of the power plant's primary and secondary circuits. This is where the main circulation pumps, steam separators, auxiliary pumps, and piping are located. The power plant is well equipped with reliable control and monitoring systems. All the reactor channels are constantly monitored automatically. These sensing elements, by way of automatic signaling units, warn of deviation from the normal in the flow of water or steam. The steam temperature is also checked. The gas pressure in each fuel channel is measured to check whether the fuel elements are intact. This system of tubes and piping, electromagnetic valves, activity sensing elements, and filters immediately warns of the slightest deviation in the operating conditions of the reactor channels. Highly sensitive equipment vigilantly monitors the reactor output. Departures from the set reactor output are corrected by the insertion or withdrawal of control rods, and the reactor output is maintained at the set level. In case the reactor output is exceeded significantly, the automatic system shuts down the chain reaction. Let's see how it works. The engineer on duty switches on the withdrawal of 3 control rods. The rods are withdrawn from the reactor. The power rises sharply. The rated power level is exceeded. The emergency protection system switches on, and the reactor is shut down. The reactor and the power plant are controlled from the control panel. The mechanism of the control and safety rods is remotely controlled from here. It is located beneath the reactor. The wide-scale introduction of automation and remote control ensures reliable operation of all the units and assemblies of the power plant and makes it easy to attend. If the reactor can be regarded as the heart of the atomic power plant, the automatic control system is its brain. Spent fuel channels are discharged from the reactor with the aid of a crane and a console-type machine. Due to the extremely high radioactivity of these channels, they are discharged by remote control. The crane and console machine operators are reliably shielded by steel, cast iron, and concrete. The portholes of the operator's cabin are made of several layers of lead glass. The crane can also be controlled from the console machine.
Беру управление на себя.
Понял, передаю управление.
The spent channel is lowered into the cooling pool. It will be kept here until it is delivered for reprocessing. The walls of the power plant rooms are coated with acid-resistant paint, and the floors are covered with special plastics. Such surfaces can be easily decontaminated by washing. All the liquid waste of the power plant is subjected to multiple decontamination in a special shop. This protects the reservoir from radioactive contamination. Complete safety for the attending personnel is ensured at the atomic power plant. The slightest radioactive contamination can be detected with the aid of radiation monitors. One may enter premises where contamination is possible only in protective suits with the permission of the Radiation Safety Service. To be subjected to sanitary treatment after work is not only compulsory, but a great pleasure. At the exit of the washroom, there is a dosimetric installation. This will not let you out if there is the slightest trace of radioactivity about you. If one of these signals lights up, go back and take another shower. Samples of air are taken from all the rooms of the power plant to make sure that it is pure. Powerful ventilators suck the air out of the power plant rooms. The air is purified in filters and released at a height of 100 meters. This is a residential area located not far from the power plant in a picturesque wooded spot. The first unit of the Kурчатова atomic power plant in Beloyarsk is making its contribution to the power system of the Soviet Union. The second unit of the power plant is under construction. Though its reactor will be of the same size, its output will be double that of the first unit. The building of the atomic power plant in Beloyarsk is a new step in the solution of the outstanding engineering and scientific problems of nuclear power. We are ready to collaborate with all the peoples of the world in the peaceful use of atomic energy, and we would be pleased if all states respond to this appeal.